All right, this is our second video in our gas unit, and today we're going to start talking about the gas laws. And when we talk about the gas laws, we're talking about how when you change one thing in a gas, how does it affect the other things in a gas? So today, the first gas law we're going to talk about deals with the relationship between the pressure of a gas, which we talked about yesterday, atmospheres, torr, millimeters of mercury, and then the volume of a gas, how much space that gas is going to take up. One of the examples that I used yesterday was talking about the water bottle. And if you make the water bottle smaller, you're changing the volume of that water bottle. Well, when you change the volume of that water bottle, you're also changing the pressure inside that container. And what that relationship refers to is what's called Boyles' law. And so Boyles' law is a mathematical equation that we're going to learn that relates the pressure of a gas to the volume of a gas. So we're going to talk about how gases respond to changes in volume and pressure. When you change the volume, how does it affect the pressure of the gas? And then we're actually going to do some calculations where the volume of the pressure is going to change, and then we're going to be able to calculate the new pressure or volume. So when you think about a weather balloon is something that they send up into the sky and that gives them some atmospheric information about the temperature, the climate, things like that. When a weather balloon goes up into the sky, what happens to it? Does the pressure on the balloon increase or does it decrease? When you think about as you go up in the air, there is less air, basically. That's why when mountain climbers climb high mountains, they have to bring oxygen tanks with them because there's not as much air basically higher up in the atmosphere. And so what happens to the weather balloon as it rises? It actually will get bigger. And the reason that it gets bigger is because the amount of air inside the balloon doesn't change, but the pressure on the outside of the balloon does. Because there's less air pressure pushing on the weather balloon. So it will actually allow the balloon to get bigger. And so as we know, as the pressure on a gas increases, the volume will decrease. So in this case, the pressure is decreasing and the volume of the gas gets bigger. The balloon grows. If the pressure on a gas increases, then the volume will decrease. And so what this shows us is what's called Boyles' law. That the volume of a fixed quantity of a gas, a fixed quantity means you're not going to add any gas, you're not going to take any gas away. So it says the volume of that gas maintained at a constant temperature, that's important, the temperature can't change, is inversely proportional to the pressure. Okay, that's a lot of information. So again, a fixed quantity means you're not going to change the amount of the gas. A constant temperature means the temperature is not going to change. So let's kind of ignore those for a second. So basically, the volume of a gas is inversely proportional to the pressure. Inversely proportional means that when one goes up, the other one goes down. So when one gets smaller, the other one gets bigger. So the way that we can mathematically write what we just wrote right here is that the volume is inversely proportional to 1 over the pressure. So if this number goes up, this number goes down. Or vice versa, if this number goes up, then this number goes down. Okay, an inverse relationship is just that. When one goes up, one goes down. Now again, let's think about, does that make sense? Go back to the water bottle. Let's see if I can draw a better one today. Probably not. No, maybe a little bit better. No, probably not. Okay, that's our water bottle, very ugly one. Okay, again, it's empty. There's no water in it, just gas. You put the lid on, so it's sealed, and you take that container and you start to push on it, and you make that bottle smaller. So now it's only this big, so this part's all gone, and you scrunched it all up. The amount of the gas hasn't changed. It's a fixed quantity. The temperature hasn't changed, maybe a little bit from your hand touching it, but not very much. But now your volume has gotten smaller. What has happened to the gas molecules that are in here? Well, they are now hitting the walls with more force, or excuse me, with the same force, but in a smaller area. So the pressure will go up. So this causes an increase in the pressure. So the volume went down, the pressure went up. Okay, so instead of writing it as a proportional, like we see here, we want to write it an actual equation. So what we can say is that the pressure of the gas, P, times the volume of the gas, V, is equal to a constant. Now, instead of using that actual constant, what we're going to do is we're going to actually just compare our initial pressures and volumes with our final pressures and volumes. Okay, so we're actually not going to use a constant here at all. This is the equation that we're going to use. This is the one that you need to be familiar with. The ones stands for the initial pressure and the initial volume. So the way we might say this first part is the initial pressure times the initial volume is equal to the final pressure times the final volume. And that is Boyle's law. So, how do we use it? Okay, let me write it out here again. P1 V1 equals P2 V2. Hopefully you're writing this down on your paper as well. It says a metal cylinder holds 50 liters of oxygen gas at 18.5 atmospheres. Now, it doesn't say what these are, but you need to be able to read this and determine what they're referring to. If they say 50 liters of oxygen gas, what information are they telling you? Hopefully you look at that liters and go, oh, liters is a measurement of the volume. And it's at 18.5 atmospheres. Where have I seen that? Oh yeah, yesterday. Atmospheres is a measure of the pressure. And it's at 21 degrees Celsius. Great, we know that the temperature can't change, so we're really not concerned about that right now. What will the gas occupy? What volume will the gas occupy if the temperature is maintained? So again, there it is telling us the temperature is not going to change, but the pressure is being reduced to 1 atmosphere. So we know that the gas is initially at 50 liters and that pressure, and the pressure is going to go down to 1. So the way we're going to set this up is just like our equation shows us. What is our initial pressure? 18.5 atmospheres. What is our initial volume? 50 liters. They want to know what is the new volume. So this is what we're looking for. The pressure is being reduced to 1 atmosphere. And then V2 is our unknown. And so to get V2 by itself, we're going to divide both sides by 1 atmosphere. And then we can see over here our atmospheres are going to cancel. Here everything cancels. And so when we do our math, we're going to go 18.5 times our 50 liters. And then if it were a number other than 1, we would divide by that number. But it is 1, so we can say that V2, our final volume, is going to equal 925 liters. Now, if you think about it, let's think about what this means. The pressure goes from 18 atmospheres all the way down to 1 atmosphere. That's a big, big drop. So you need a lot more space for that pressure to go down. So the volume had to increase dramatically, which it did. It went from 50 all the way up to 925 liters. So that's a big, big increase in our volume. Okay, here's another example. The gas pressure in an aerosol can is 1.5 atmospheres. Now here they're actually telling us the pressure is this. They don't really need to tell you that because you should be able to look at that ATM and determine, oh, that's my pressure. With the volume, again, they're telling you 6.23 liters. It says if the pressure is changed to 1,352 millimeters of mercury, what will the new volume be? So again, we've got our equation, P1V1 equals P2V2. So our initial pressure is our 1.50 atmospheres. Our initial volume, they tell us, is 6.23 liters. Our new pressure, And here's where you hopefully are stopping to think and going, uh-oh, we got a problem. Because if this pressure is in atmospheres and this pressure is in millimeters of mercury, those are not going to cancel. And so before I even continue, I'm going to stop right where I'm at, and I'm going to do what I learned how to do yesterday. I'm going to take 1,352 millimeters of mercury, and I'm going to convert that to atmospheres. And I need to remember those relationships. I know that 1 atmosphere, my relationship is 1 atmosphere equals 760 millimeters of mercury. So if I want to cancel millimeters of mercury, I'm going to put that on the bottom. I'm going to put 1 atmosphere on the top. And now I'm going to take 1,352 and I'm going to divide it by 760 millimeters of mercury, and that gives me, let's see, I used 4 significant digits here, so I'm going to say 1.779 atmospheres. And now I can use this number up in this equation so that my atmospheres will cancel each other. So my final pressure is actually 1.779 atm, and then again they want to know the volume, so my V2 is my unknown value. So I've got to get V2 by itself, so I'm going to divide both sides by 1.779 atm. 1.779. Here the whole thing cancels. Here the atmospheres will cancel. So to do the math, I'm going to take 1.50, I'm going to multiply by 6.23, and then I'm going to divide by 1.779. And I get a final answer, so let's come down here just because I'm out of room. V2 equal to, it looks like we got 3 digits as our lowest value, so we're going to say 5.25 liters. Again, check the math, make sure my math is correct, but I got an answer of 5.25 liters. Now, let's check and make sense. Does that make sense? What did the pressure do? The pressure was 1.5. It went up to almost 1.8. So the pressure increased. If the pressure increases, we know that it's an inverse relationship. So if the pressure increased, then the volume should have decreased. And it did. It went from 6.23 liters down to 5.25 liters. All right, let's look at another one here. It says a gas under 6.25 atmospheres of pressure occupies 22.4 liters. Now again, hopefully again, pressure, volume, because you see those liters. The volume is going to increase to 37.4. What's the new pressure? So our initial pressure is 6.25. So that's our P1. We're going to times it by our V1, 22.4 liters, is equal to our P2, which is our unknown, times V2, which is 37.4 liters. So let's do this one a little bit quicker. I'm not going to actually show it, but I'm going to take 6.25 times 22.4 divided by 37.4 to get the P2 by itself equals 3.74, and hopefully we can see the liters cancel, so we're left with atmospheres. So then we're just going to check our question one more time. What will the pressure be? We've got the pressure, but then it says in torr. So our final step, once we get our answer, is we need to convert our 3.74 atmospheres to torr. So 1 atmosphere we know is equal to 760 torr. So we're going to take our answer, and I'm not going to use 3.74. I still have my calculator up that has the 3.74, 33155, whatever. And I'm going to use that number. That gives me a better overall answer. So I'm going to multiply that times 760. And again, all of these have 3 significant digits. So my answer is also only going to have 3 significant digits, 2,840 torr. So my atmospheres are gone. All I have left is torr. And that is my final answer. Okay, so just a quick recap here. What happens to a gas when the pressure increases? The volume must go down. If the volume increases, what must the pressure do? The pressure must go up. If the volume decreases, what must the pressure do? The pressure must, if the volume increases, the pressure goes down. If the volume decreases, the pressure must go up. It must increase. Okay, and then we can use Boyle's law and we can solve for any 4 of them. So if we have P1 V1 equals P2 V2, you should be able to write that equation to solve for P1, for V1, for P2, or for V2. Like if I were to ask you what's the equation to solve for the initial volume, you should be able to say initial volume equals P2 V2 over P1. And then again, some of the ways that they'll try to trick you a little bit is they'll have those pressures in different units and things like that.